Hello guys and welcome to another episode of how a computer actually works, and in this episode we'll be looking at how registers are and buses are used to remember any data, and how one specific register can memorize if we want it to. So how register and bus works together. So I'll be As you can see that there are three register currently here, and you can this is actually a three-way bus, sorry, an eight-way bus. So there are actually eight wires here. I have just drawn two to make the diagram more simplified. So just take that if there is a bit A, B, and there are eight of the wires, and suppose the four of them are A and four of them are B, so there will be from this part it will go to this, and also this, and the BA will go through this whole wire. And I think you should know that because we have just watched how the bus works in the previous video, and if you don't, you can watch the previous video so that you understand this video. So now I'll be saying how a register can remember data, and if we want one register to remember data, how we can just select that register to remember the data. First of all, I didn't actually draw two things of this register, and those are the setter and the enabler, which you all guys should know what actually are. The setter enables that enables when the setter is on, it enables the register to memory, and also if the enabler is on, the register now currently remembers the current bit. So let's see, if all of the setter or S is turned off and also the E bits are turned off, then each of the register will be set the way it is. So if these S and E are all off, then the register will be whatever they currently are. And suppose we want to copy data from R1 to R3. Okay, let me just use another color, bigger brush. R1 to R3. So we want to copy the data of R1 to R3. First, you have to turn on the E of the R1, or the enabler of the R1. So now the R1's data, if we turn the E on, then the data is available on the bus. So if this E is on, then whatever R1's 8 bits are, it will all be floating or traveling around the bus and will be available to all of the bus. So that means that these bits are now traveling in the bus currently if the enabler is on of R1. And then we want to copy it to R3, and so we will have to turn the setter of the R3 setter on briefly, which means we don't have to keep it on, and we'll just have to, when this R1's E is on, R1's E is on, then we'll have to just make the R3's setter on for a while, and if this is turned on, the then this register R3 will can't now remember the whatever the data R1 is passing on by enabling its enabler. So using this, we can now copy data from R1 to R3. So that was a very short lesson, and so now we'll know how bus and register copy data from each other, from one register to another. So now I'll just clarify some doubts that some may have, which is when the E bit of R1 is on, bits in R1 is now currently traveling at a bigger space. because this is now connected to the bus. So the enable bits will now travel to the all of all part of the bus. But if the enabler is off, then the bits will be confined to this register only if this bit is off. And when we turn on the enabler, then this bit will be able to move to all of the registers here, all of the buses here, all of the buses here. And when the S bit of the R3 is on, R1 now consists its own, but the R3's current bits will be changed to that of the R1s. If anything now, then the R4 would change with R1. If the R1 is also changed, then R3 will also be changed. When the S bit of R4 is R3 is then off, R3 will then again separate will become a separate byte and will currently be that of the R1, and so it will have the byte same as that of the R1. And when then again we turn off the R1's E, then the bus only becomes R1 and the bit stop moving through the whole bus and it won't come anymore. And if this enabler is off, then all of this bus will not consist of R anymore. And now I'll just be drawing some diagrams which are similar to this. Register 1 is 1 register, R for register enabler setter, same as this type. And here this is the input or output, such as this is the input or this is the output, or vice versa. Then another, this register part is the same as what I have just drawn. This one is same as that, this part, so this and this are actually same. Then another diagram we have is, another diagram is, maybe it's just the same, R, this is just the same as before but has a different type of wiring, IO for input output. And also a same diagram for register like this, are again the setter and enabler. And maybe this one is the same as the current one, because here we have this black stripe part. And you may be wondering why I did my video on white today, because I wanted to make clear the black and white part. And so this part and this part is actually same, and also with this part. So that's all. Hello, and I'm sorry if you have thought that the video has ended. Apparently I didn't say some of the infos I needed to, and I seem to forget, so now I'll just be talking about those, some clarifications again. And one is moving byte clarification. In the above example, when the R1's byte was copied to that of R3, we can say more appropriately that move R1's data to R3, or move the byte from one over to another. But actually in reality we don't move the byte from R1 to R3, we just copy it, so that R1's data is still there and R3 will just receive that of data of the R1. So R1's data didn't actually move, it stayed there, we have just copied the data from R1 to R3. Also, the content of R1 does not leave place from where it came, so the from or R1's data has not been changed, which I have just talked, but I want to say it again. And where the information is taken to, or R3 was lost and is now replaced by the current R1's value. And so that's all of the clarifications. I just wanted to clarify the moving bytes that people would generally get confused with, but we don't actually move the byte, we just copy it from one place to another. And so that's all for today, and I hope you liked it, and stay tuned for more videos. And that's all for today. Goodbye. If you want to learn more about how computer works, you can look read this book called But How Do It Know, written by Clark Scott. All of this material I have been using is actually taking help from this wonderful book written by Clark Scott about how actually a computer works, and it is for everyone, so everyone will be able to understand the simple language. And I have been using some of this content to create my videos. However, some of the content are copyrighted by Clark Scott by himself, but I have been given permission to use it. So anyways, if you want to learn more about how computer works, you can check this simple written book, But How Do It Know.